Good morning, everyone. Today we're going to be talking about angle and trigonomic values. So before we start, we should know about angles. An angle is formed by two rays that share a common starting point. One ray is called the initial side, where the angle begins. The other ray is the rotating side, which moves to form the angle. So first, let's start with standard position angles. Standard position angles are angles measured on a coordinate plane. The measurement starts with the positive x-axis, known as its initial side, and rotates counterclockwise to the terminal side. Note that if the angle rotates counterclockwise, it's positive. However, if it rotates clockwise, it's a negative value. Next, we move on to coterminal angles. These are angles that share the same starting and ending sides, but differ by the number of full turns they make. For example, a 45-degree angle and a 405-degree angle are coterminal because 405 degree is 45 degrees plus one full turn. Likewise, a 300 negative 315-degree angle is coterminal with 45 degrees because it's 45 degrees minus one turn. Finally, let's talk about reference angles. A reference angle is the smallest positive angle between the terminal side of an angle, the x-axis. It's always an acute angle and helps simplify trigonometric calculations. For instance, if the given angle is 270 degrees, the reference angle is 45 degrees. Next, we move on to solving trigonometric values. In a right triangle, we use trigonometric ratios like sine, cosine, and tangent to relate the angles inside. However, for special angles such as 30 degrees, 45 degrees, and 60 degrees, we have known ratios that make the calculations easier without needing a calculator. So let's test these on a few examples. First is a 60 degrees. The angle 60 degrees is on the first quadrant, where all trigonometric values are positive. So first thing we have to do is label the triangle sides. As you all know, 60 degrees is opposite is the square root of 3 divided by 2, while its adjacent is 1 over 2. So to find sin, all you have to do is substitute it for y, which is square root of 3 over 2. For cosine, you have to divide 1 over its y. So 1 divided by square root of 3 over 2 is equal to 2 square root over square root of 3, which equals to 2 square root of 3 over 3. Next, we move on to cosine. For cosine, we only have to simply substitute its x, which is 1 half. Meanwhile, for sec, we have to divide 1 to its x. So 1 divided by 1 half is equal to 2. Next, we move on to tangent. For tangent, we divide y over x. So in this example, you can see next square root of 3 over 2 divided by 1 half, which equals to 2 square root of 3 over 2, which in turn becomes square root of 3. For cot, we only have to divide x for y. So in this example, you have to divide 1 half the 2 square root of 3 over 2. This results to 1 over square root of 3, which results to square root of 3 over 3. Next example I have is the angle 240 degrees. The angle 240 degrees is in the third quadrant, where the sine is negative, cosine is negative, and tangent is positive. Its reference angle is 60 degrees. So, first is relabel the triangle sides. This is similar to the first example, where they have the same sides. So next, we solve its trigonomic values. The answers are the same with the first example, as you can see that they both have the same angles and the same given sides. So let's move on to the negative 15 degrees angle. In this picture, you can see that the, the angle is turned on clockwise. So an angle negative 315 degrees is equivalent to 45 degrees. Since adding a full rotation gives negative 315 degrees plus 360 degrees, 45 degrees. The reference angle is 45 and it's in the first quadrant. So first, we label the sides. For a 45-degree quadrant, we have the sides being the hypotenuse being 1, the opposite the opposite being square root of 2 over 2, meanwhile the adjacent being negative square root of 2 over 2. For solving its trigonomic values, it's the same as the first few examples. For for its sign, you only have to substitute its opposite. So it's negative 2 square root of 2. For its cosine, it's 1 over y. So you simply have to put 1 divided by square root of negative square root of 2 over 2, which in turn turns to square root of 2. For its cosine, you only have to simplify x. You only have to substitute x, which is square root of 2 over 2. For its sec, what you have to do is divide x by 1 by x, which is 1 divided by square root of 2 over 2, which equals to 2. For tangent, you divide y by x, which results in negative I square root of 2 divided by 2, I square root of 2 over 2 divided by negative square root of 2 over 2, which equals to negative 1. For cot, you only have to divide x by y. So you divide square root of 2 over 2 divided by negative 2 over 2, which equals to negative 1. Lastly, we have the 90-degree angle, negative 90-degree angle. So this angle is on the negative y-axis, so it has its own unique trigonometric values. As you can see, its opposite is 1, while the adjacent is 0. So how do you find this? You simply do the same things as you have done in the same examples. For sine, you only have to substitute, which is 1. For CSC, you divide 1 over y, which turns into 1. For cosine, you only have to substitute x, which turns to 0. For secant, you cannot divide 1 and 0, meaning the secant of negative 90 degrees is undefined. This goes for the same as tangent, as dividing negative 1 to 0 will result to undefined. Lastly, we have cot, which is 0 divided by 1, which in turn becomes 0. That's all for today. Thank you for listening, and good morning.